Welcome to the geometry recording for the week of November 3rd. So welcome to November. Hopefully everybody had a great Halloween weekend. We are also in the week of, we're week 12. So when you go to do the assignments this week, make sure that you're looking for the folders that are marked week 12. Make sure that you've got your math notebook out and that you're ready to take good notes as we go through some things that you're going to be seeing this week. If you take good notes, you're going to have an easier time with all the assignments this week. And I do have a warm-up that I would also like you to complete in your math notebook. This warm-up problem takes us back to review what we did last week, where we were learning about polygons, and this particular warm-up is focusing on the exterior angles of polygons. So what you're going to do is you're going to look at this figure below, and you're going to first find the value of y, and then once you find the value of y, you're going to find all the measures of each of the exterior angles of the quadrilateral. So go ahead and click pause now so that you can work through this on your own, and when you're ready to check your work with mine, go ahead and click play. Alrighty, so let's review what we learned last week, not last year. Maybe you learned something about exterior angles last year, but what did we learn last week? So let's first start with the exterior angle sum theorem. Remember, sum is when you add a bunch of numbers together, it's what you get. That is your sum. So the sum of the measures of the exterior angles, so the sum of the exterior angles of a polygon where you have one angle at each vertex is going to be 360 degrees. So if we were to add each of these exterior angles in this polygon, we would get 360 degrees. So we would get 360 degrees. So knowing this, we can work backwards now to find one exterior angle. So the measure of each exterior angle of a regular polygon is going to be 360 divided by n, and remember, n is always going to represent the number of sides in the polygon. So remember, we see this word regular, and remember, regular means all congruent sides. So if you have a regular polygon, that means that you're going to have a polygon with all equal sides. So let's take a look at our example here. Now that we've reviewed the exterior angle theorem, how can we find the measure of y? Well, we just reviewed that if we add all of our exterior angles together, we should get a total of 360 degrees. So let's go ahead and set up an equation to show that. Y plus 2y plus y plus 2y. If we add all those up, we should get a total of 360 degrees. So now we've got an algebraic equation where we're just going to solve for y. We're going to combine all of our like terms. We've got y, 1y plus 2y, that's 3 y's, and we've got 3 more y's over here, so that's a total of 6 y's equals 360 divided each side by 6. And we get y equals, well, what do we get when we take 360 divided by 6? You can grab your calculator if you need to, or this one is probably, you can do this one in your head. So 360 divided by 6, we get 60 degrees. So y equals 60 degrees. So all these angles with just plain old y, we know that they're 60 degrees. If it's 2y, we have to take 2 times 60, which would give us 120 degrees. If we add all those up, we will get 360. So remember, the exterior angles will have a sum of 360. All right, just some reminders. Make sure you're checking your grade tab frequently. Look for missing assignments. Look for assignments that maybe you started but forgot to finish. As we start in Unit 3, you're going to notice that I added a resource folder in the units. So when you go into the units folder, you're going to see that there's, at the very top before even Unit 3 Session 1, there's a resource folder that's going to list all the properties of quadrilaterals. As we work our way through Unit 3, we're going to be learning lots and lots of properties of all the different types of quadrilaterals. And the websites that I'm putting in that resource folder are going to help you keep track of all of them. So just some helpful websites that are going to help as we're working through Unit 3. So make sure you check that out. And then remember, you do need to submit, let me know when you submit late or redo work. I'm still getting students that are not doing this, and if you're not doing that, I'm not going to be able to know that you did those assignments, and you're not going to get those graded. So you need to let me know when you are submitting late work so that I know to grade those. If you don't, your work will not get graded. And you do need to tell me the specific assignments that you turned in late. Don't just say I submitted a bunch of work from Unit 3, or you need to tell me specifically what assignments you did. Alrighty, what are you learning about this week? So we are going to learn about parallelograms. And then we're going to take a quiz that covers sessions 1 through 4, and then you're also going to continue to dig deeper in parallelograms and learn about what the conditions are for parallelograms, or really what makes a parallelogram special, or what can you use to prove that a shape is a parallelogram. Alrighty, so what are parallelograms? What are parallelograms? After today, after watching this recording, you're going to know what parallelograms are. So a parallelogram is a four-sided figure, and let's get more specific about that four-sided figure. Both pairs of opposite sides are going to be congruent, so the opposite sides will be congruent. So if you look at this figure up here, the opposite sides are going to be congruent. So to have a parallelogram, the opposite sides have to be congruent. Consecutive angles are supplementary. So what does consecutive mean? So consecutive means angles that are right next to each other. So angles A and B are consecutive, or these two angles right here, those are consecutive angles. So if we add those up, they're going to equal 180 degrees, because that's what supplementary means. So angles that are consecutive, when you add them up, you're going to get 180 degrees. So those would add up to equal 180 degrees. You can also have these two angles right here would also be consecutive. They just have to be next to each other. And when we add those angles up, they're going to be supplementary, or they're going to equal 180 degrees. Both pairs of opposite angles are congruent. So opposite angles are congruent. Those two would be congruent. And I'll do another set. I'll do double arcs to show that then. So opposite sides are going to be congruent of angles. Diagonals are going to bisect one another. So a diagonal is just when you go, I'm going to erase those marks in there so I can draw in some diagonals. It's when you go from one vertex across to the other side. So that's what a diagonal is when you go from one vertex across to the opposite vertex on the other side. And those, they're going to bisect each other. So when they bisect, that means that each of those segments will be congruent. So that is something that is a property of a parallelogram. And then opposite sides are parallel. So we can use arrows to show that sides are parallel. So when there's arrows like there, that lets us know those two sides are parallel. And then I could draw in some additional two arrows to let us know that the other two sides are parallel. Lots of things, so make sure you write down all these properties in your math notebook about parallelograms. And we're going to use these properties to help us solve for some unknowns. So we have a lot of tools now about parallelograms. They're going to help us solve for all sorts of unknowns that might be thrown at us. So let's get a visual now of the properties of parallelograms. Remember, they're always quadrilaterals. That means four sides, two sets of parallel sides, opposite sides of their angles or opposite angles will be congruent. Opposite sides are congruent. And then the diagonals will bisect each other so that each segment, this segment here will be congruent to that segment. And then this segment here is congruent to that segment. And then two adjacent or consecutive angles will add up to 180 degrees. All right, so let's use all of what we just learned to answer a question about parallelograms. So here we're told that this figure ABCD is a parallelogram. So it's got all those properties that we just learned about. We need to find the value of x. We need to find the value of x. So how can we find the value of x? So we might need to find the value of z first. So that's going to be your clue. See if you can maybe figure this out. Can you solve for z first? Well, here's two angles that are consecutive, or they're right next to each other. They're adjacent angles. What did we learn about the measures of adjacent angles? They have to add up to 180 degrees. So here, let's set up an equation where if we add these two angles up, they have to add up to 180 degrees. So we can't solve for x without first knowing what z is. And then once we know z, we can solve for x. So that's what we're doing here. So combine our like terms, z plus 2z, that's 3z minus 15 equals 180. We're going to add 15 to both sides to help us solve for z. So now we've got 3z equals 195. And then our last step is to divide each side, 195 divided by 3. And when we do that, we get z equals 65. So remember, that's the value of z. So we got to plug that in now to find our angle measurement. So 65 minus 15 is 50. So this angle measurement right here is 50 degrees. 50 degrees. We know 2 times 65 is 130 degrees. And we also know that because we knew something plus 50 had to add up to 180. So now, can you figure out what the measurement of x is going to be, that angle measurement? So remember, 2 consecutive angles, so now we can look at this angle and this angle is consecutive. They have to add up to 180. We also learned that angles opposite one another are congruent. So what would be the measurement of angle x? Well, these two angles would have to be congruent, so it would also have to be 130 degrees. And it would also allow us to have that supplementary 2 consecutive angles. So 130 degrees. So we were able to apply what we learned about the properties of our angles in parallelograms. Alrighty, so here, your task, find the values of x and y and the measurement of angle ABC and measurement of DAB. So lots that we need to do. So let's review what we know about parallelograms. So we know that, let's try and solve for x. So let's look at x. So we're trying to find this measurement of x, and x that's part of one of our diagonals. So what do we know about the diagonals? The diagonals bisect each other. So we know that segment DE has to be congruent to segment EB because we know that the diagonals bisect one another. We know EB is 15, so that means that DE must also be 15. So that just allowed us to find our value of x. So we did that. What about y? Can we solve for y? So let's find where y is. Y is one of the sides. So here's our y. What do we know about the sides of parallelograms? What do we know about side AB and side DC? We know that opposite sides are congruent. So we can set up an equation to help us solve for y, knowing that both sides are congruent. So we know that side AB has to equal side DC. We know that side AB is represented by 2y and DC is 22 units. So we can solve for y now by dividing each side by 2. Y would equal 22 divided by 2 is 11. So we were able to solve for y. So y would equal 11. What about some angle measurements? Angle ABC. So I'm going to get rid of If you need to click pause to take some good notes about what we've done so far, go ahead and do that because I'm going to erase everything that I've marked here so that we can focus on the angles. Alrighty, so angle ABC, ABC, so that's this angle right here that we need to figure out that measurement. So what do we know about the angles of parallelograms? We know that the consecutive angles have to be supplementary. So angle C is consecutive with angle B. So what's the measurement of angle C? So we would have to add 31 plus 18 to figure out what that entire angle measurement is. So 31 plus 18, what is that, 49? So the measurement of angle C is 49 degrees. So knowing that, let's go ahead and let's do a little box here. For the measurement of angle C plus the measurement of angle B has to add up to 180 degrees. Well, we know the measurement of angle C is 49. We don't know the measurement of angle B. That's what we're trying to figure out. But now we have enough information that we can figure that out. We can subtract 49 from both sides. So 180 minus 49, what do we get? 180. That's 131. So the measurement of angle B is 131. And that, by the way, is the measurement of ABC is 131. Get specific there. And then we're going to stop there just because I want to get more in. So we've done enough practice with angles, bisects here, or angles, the diagonals, and the sides. We really got to use all of our properties of parallelograms here. Alrighty, and we're going to do one last practice problem where if we can prove that a quadrilateral, can we prove that a quadrilateral is a parallelogram? And what do we know about parallelograms? Remember, we know that opposite sides are parallel. So we've got a bunch of coordinates here, and you're going to have a problem like this in your homework this week, and that's why I'm showing you this right now. So the first step is let's plot all of our points. So we've got point A is at -3, 2. So I'm going to go ahead and plot that and label that point A. Point B is at 2, 2. I'm going to go ahead and plot that. C is at -5, -1. Plot that, label that point, and the last point is at -3, 1. Did I get all those right? -5, -1, 2, 2, -3, 1. That one, something's wrong. That's not the right last point there. Let's see. This is the point that we want. So last point is going to be at 0, -1. We're going to change that. Alrighty. So is this a quadrilateral a parallelogram? So let's, if we draw in our lines here to make it create some kind of four-sided figure, is it a parallelogram? Well, how can we tell? So we know that opposite sides are parallel if it is in fact a parallelogram. So looking here, I'm looking at side AB and side CD, and those are both straight lines. They're horizontal lines. So we know that both of these are going to be parallel. We know those are parallel. But our sides AC and BD, are those parallel? Well, let's find the slope because we know that parallel lines have the same slope. So remember, we learned last week that parallel lines have the same slope. Whoops. Oh goodness, I'm having trouble spelling slope today. I don't know why. Alrighty, so let's find the slope of line AC. So what is the slope? So remember, we figure out the slope from going from one point to the next, rise over run. So to go from point C, we're going up 3 and over 2. So it would be 3 over 2. That's our slope. What is the slope from of line BD. So again, we're going rise over run. So we're going up 1, 2, 3 units, and then we're going to the right 2 units. So rise over run. So since these two lines have the same slope, we can say that these are in fact parallel lines as well. So these two lines are parallel. AC and BD are also parallel. Because they are all sets of opposite sides are parallel, we know that this is in fact a parallelogram. Alrighty, so that's it for today. This means we are ready for the week of 11-3, the key phrase assignment. And I want you to tell me one thing there's going to be 2 parts here. One thing you learned about the angles. So we learned a couple things about the angles of parallelograms. I want you to tell me one thing. And then I want you to tell me one thing you learned about the sides of parallelograms. So tell me one thing you learned about the angles and one thing you learned about the sides of parallelograms. And that's all you need to do this week for your key phrase assignment. Remember, so we learned about the angles, and tell me one thing you learned about the sides. So you're going to tell me a total of 2 things. Let me know this week if you have any questions as you're working through your assignments. Have a great rest of your week.